To find the probability of an event E, we calculate the cardinal number of the event and we divide by the cardinal number of the sample space. This is going to be true for both theoretical and empirical probability. Now, theoretical probability is based on equally likely outcomes in a predictable sample space. So those were the situations we talked about, such as rolling a die, or drawing one card from a standard deck of 52, or even calculating the probability that a certain disease occurs in an offspring. So the sample space is predictable, and each event in that sample space is equally likely. For example, it's equally likely that I roll a 2 on a standard die that I roll a 5 on that standard die. So how is this different from empirical probability? Empirical probability applies to situations in which we observe the relative frequency of events in order to make predictions about the future. So we're looking at the history. How many times did a particular event occur over a given period of time? And based on that frequency, we can make assumptions or predictions about the future. This applies to sports averages, weather patterns, and even public opinion polls. Those are based on empirical probability measurements. Again, because they don't have a predictable sample space, but they do have a history. So, for example, in a survey of 100 people regarding their political affiliation, the following results were obtained. So in this particular political poll, we have a couple of categories. Was the person a Republican or a Democrat? Was the person a man or a woman? So notice we had a total of 100 people surveyed. We can see that in the bottom right corner. And we can also see the total Republicans and Democrats. Those are summed vertically, and we can see the total men and women that participated in the poll. Those are summed horizontally. So let's calculate the probability that a woman is a Democrat. So notice we are narrowing our focus from all 100 people in the survey to just the women in the survey. So I'm going to be looking at this row right here. Now, of the women, 35 were Democrats, and there were a total of 60 women that participated. So we could say 35 women out of 60 were Democrats. Let's go ahead and reduce that to be official. You've got a common factor of 5 in the top and the bottom. 35 divided by 5 is 7, and 60 divided by 5 is 12. So the probability that a woman is a Democrat, according to this particular poll, is 7 out of 12. Now again, this is empirical probability. You could use this to make predictions about the likelihood that a woman is a Democrat in a particular region. You could extrapolate that to other regions, but again, it's not as predictable as theoretical probability. It's based on history and patterns in local regions. Example B, what is the probability that the participant is Republican? So notice we're looking at a more general question on this one. We're looking at all participants, and we want to know how many of those are Republicans. So I'm going to look at the total Republicans, whether man or woman, 55 out of a total of 100 people. Let's go ahead and reduce by 5. 55 divided by 5 is 11. 100 divided by 5 is 20. So as a fraction, we would say the probability is 11 out of 20. Now, if I look at the number before I reduced it, it's 55 hundredths. We can easily convert that into decimal as 0.55, 55 hundredths, or 55%. Percents may make a little more sense to your brain than something like 11 out of 20. So a little more than half of the participants were Republicans. So do keep in mind we're using the same probability formula to calculate empirical probability, but empirical probability is based on gathering evidence, making observations about patterns, looking at the history of particular events, and using that to predict the future of events. Again, theoretical probability comes from being able to list every single possible outcome in an event. Let's look at example 8. A player with a 200 batting average means that he has gotten a base hit 2 out of every 10 times at bat. And again, that's based on the particular player's history, right? So this is an example of empirical probability. A player with a 400 batting average is even more likely to get a hit. That is 4 base hits out of every 10 times at bat. If a player with a 300 batting average goes to the plate 200 times in one season, how many hits, let's make this specific, base hits would you expect him to get? Well, looking at the pattern, again, a 200 batting average means 2 out of 10 is the probability that he'll get a base hit. A 400 batting average, that means 4 out of 10 times he gets a base hit. So if we're looking at a 300 batting average, that means 3 out of 10 hits he will get a base hit. Now, if the probability is 3 out of 10 and he goes to the plate 200 times, we're going to multiply to figure out how many times would we expect him to get a base hit. Now I'm going to go ahead and reduce this before I multiply. 10 goes into 200 20 times. So I can multiply straight across. 3 times 20 gives us 60 base hits. So if his batting average is 300 and he goes to the plate 200 times, we can expect he's probably going to get base hits. Now remember, probability is not a prediction. It is an educated guess about an outcome in the future. Now, empirical probability is also used in weather patterns. For example, the Farmer's Almanac indicates that the temperature in a certain city reaches 100 degrees for 22 days in the month of July on average. So what is the probability that the temperature is 100 degrees on one specific day in July, that is July 4th? Well, let's look at the probability. 22 days out of all of the days in July. So the probability that we get 100 degrees on July 4th is going to be 22 out of, notice there's 31 days in July, so 22 out of 31. Let's go ahead and convert that to a percentage. 22 out of 31 gives us approximately 0.71, or a 71% chance. So that is pretty likely that it's going to be 100 degrees on the 4th of July. So bottom line, empirical probability is calculated using the same formula as theoretical probability, but instead of looking at the events in the sample space, we look at things such as data gathered from a poll, or historical behavior such as a batting average, or even the historical behavior of the weather, using that to predict and measure the future. So this completes our Chapter 11 study on counting principles and probability. So once you finish all of your homework, you're ready to begin that review and begin that Chapter 11 exam. So as always, best of luck on that exam.